For countless generations, humans have felt the sun's warmth and watched it rise and set. Some societies have literally worshipped it. And yet, until quite recently, the sun was a mystery. No one really knew where it came from, what it was made of, or why it gave off light at all. Today, the situation is different. Because we've learned to read something called the electromagnetic spectrum, we know a lot about the sun and are learning more every day. Here's how it works. Like most stars, our sun is basically a big nuclear furnace. Deep inside its core, immense gravitational pressure fuses hydrogen into helium. These reactions release a tremendous amount of energy in the form of electromagnetic radiation. Because our sun is huge and dense, the particles that carry this energy, called photons, can take thousands of years to reach the surface. But once they break free, it's about an 8.5-minute journey to Earth. The photons that carry energy from the sun travel in the form of waves. Alternating electric and magnetic fields push each other forward at the constant speed of light. But even though they travel at the same speed, not all photons pack the same punch. Those that carry more energy oscillate more quickly, with a shorter distance between the crest of each wave. This distance between one crest and another is known as the light's wavelength, and the shorter it is, the more energy the light carries. Together, the entire range of possible wavelengths is known as the electromagnetic spectrum. Every second, the sun emits light across different parts of the spectrum, from low-energy radio waves and microwaves to high-energy X-rays and gamma rays. The problem is, our eyes are tuned only to a narrow sliver in the middle, the so-called visible light range. In the early 1600s, scientists first learned how to magnify this light from the skies with glass lenses. Continued improvements helped astronomers see the sun's surface in more detail. But no matter how large the telescope, there's only so much we can learn from looking at visible light. The real revolution in astronomy has come with our ability in recent decades to see a much wider range of wavelengths. Additional layers of the sun, which burn at much higher temperatures, became visible. And ever since, the dynamic life of our sun, and all stars, has been coming into focus.